Okay, today we're going to go over 4.1, which is higher powers. So far we've been studying only x to the first or x to the second. Now we're going to get into x to the third, x to the fifth, x to the fourth, way higher powers in this chapter. There was one answer to x to the first because the highest power was 1. What does that mean? It's where it crosses the x-axis. Same thing with this one. There's two answers because that's where it crosses the x-axis at. We are going to study higher powers. If there's 5, it's going to cross 5 times, and so on. Okay, we're going to learn how to graph first of all, and it's very similar from the last chapter. The highest power is the 3. What does the 3 make? It makes a snake. Since it's a negative 2, though, the snake is going to look like this. The 2 makes it skinnier, it flips it, and it's x to the third. So, what does c to the negative 2 do? It shifts the graph down 2. So I'm going to shift my graph down 2, and I'm going to make my same graph. This one gets shifted up 3, and I make my same graph. So part 1 is very similar to what we did in the last chapter. Part 2, very important. The intermediate value theorem. In the calculus book, they call it the IVT. It proves that you will get a 0 between 2 points if the y values are opposite of each other. So this is what you're going to do. Your x equals a negative 3, you're going to make an ordered pair. X equals 2, you're going to make an ordered pair. And then what you're going to do is you're going to plug a negative 3 in for all of your x values. When you plug a negative 3 in for x values, you're going to get a negative 12. Then what you're going to do is plug a 2 in for all the x values, and you get 33. So, if I graph this, will I cross the x-axis? Let's just graph it really quick. Here's a negative 3, and here's about a negative 12. Here's a positive 2, and here's a positive 33. Will my graph cross over the x-axis? And it does, because the y values are opposite of each other. This is what the graph is going to look like anyway. It's going to start down, and then it's going to go up, and then it's going to stay up. So did it cross over the x-axis? Yes. I'm going to erase this. I'm going to show you a chart here. So you're just proving that these two are opposite of each other. On the test, I need you to make a little grid here. And in this book, they make the XY chart horizontally. On the test, they're going to give you like a negative 3, a negative 2, a negative 1, 0, and 1. Those are your x values. And then the y values are like 7, 8, negative 4, negative 5, and a negative 14. They're going to give you the x values. They're going to give you an equation. You need to fill the x values in to figure out what the y values are. And then on the test, they're going to ask you where in between which two x values do you cross over the y-axis. And it's right here because your y values are opposite signs. So between a negative 2 and a negative 1 is where this graph, I'm not talking about the one up above, I'm just talking about a totally different graph, would change signs. Why wouldn't it cross the x-axis here? Because they're still negative. They're not going to cross over if they're both negative. Make sure you know how to make one of these, because you're going to see this on the review sheet, you're going to see this on the test. Again, the only way you can cross over, if this was a negative 2, comma 4, and there's another point over here, 3, comma, negative 7, if you want to connect the two dots, Will you ever cross the x-axis? Yes, because the y is positive here and the y is negative there. There has to be. You have to cross. There has to be a crossing between a negative 2 and a positive 3. Okay, the next section will take a little bit. They want you to match the graph with its equation. We need to review things back from Algebra 2. So what I'm going to do is I'm going to review the end behaviors that we went through in Algebra 2. So let's scroll down and let's go over the end behaviors that we did in Algebra 2. And hopefully you'll remember this. If it's an even function, like x to the second or x to the fourth, this is what the graph is going to look like. What's the end behavior? They both end up facing up. I think you remember this from Algebra 2. If it's an even function, but it's a negative out in front, something like this, what is your graph going to look like? It's going to be facing down. What does the end look like on your graph? They both are facing down. If it's an odd function, like x to the third or x to the fifth, it's going to look like a snake. It starts down and it ends up. It starts down, it ends up. And last one, if it's odd and it's a negative function, it starts up and it ends down. So let's go back to what we were doing before. Again, you should know this from Algebra 2. We went through all of this. They want you to match the graph with the equation. So there's two things that you learned in Algebra 2. If I put the first one back together again, isn't my highest power x to the third? It's a positive odd. A positive odd starts down and ends up, right? It can't be the first one, and it can't be the one below the first one. It can only be these two. It starts down and ends up. It can only be those two. Okay, which one of those two would it be? It crosses the x-axis at 1, and it crosses the x-axis at 0. That's another thing that you learned in Algebra 2. Which one of those has a crossing at 0 and 1? This one is the only one that has a crossing at 0 and 1. So this has to be the A. Okay, look at the B now. If I put this back together again, isn't this going to be a negative x to the third? A negative x to the third starts up and ends down. It can only be B, because that's the only one that starts up and ends down. Okay, the next one. If I put these all back together again, my highest power is x to the third. It's very similar to A. There's only one possibility it can be. It's C. I just want to make sure that you know why it's C. It's x to the third. It starts down and ends up. It crosses it at 3 spots. It crosses it at a negative 2. It crosses it at a negative 3. And it crosses it at a positive 3. Do you see the 3 spots? And then the last one, if I put this all back together again, it comes out to be x to the fourth. A positive x to the fourth starts up, ends up, so it can only be for that one. Okay, the last part of the assignment. I'm just going to do 2, and then we're done. They want you to find all the values where the y is greater than 0, and all the values where the y is less than 0. First thing I'm going to do is I'm going to graph this. If you have a graphing calculator, you can graph it, but I want you to be pretty precise, so I think doing it the long way isn't going to make or break you. So the first thing I'm going to do is take the GCF out. I'm going to take the x out, and I'm going to get 9 minus x squared. I'm going to factor it one more time. I'm going to get x, parentheses 3 minus x, 3 plus x. This is important to factor it because then I know where it crosses the x-axis at. It's crossing the x-axis at 0, 3, and a negative 3. And I'm going to put those 3 spots down. Those are the three spots where it crosses the x-axis at. Okay, now comes that end behavior. I know my highest power is a negative x to the third. What kind of a start does it have if it's a negative and odd? Negative and odd. It starts up because it's negative and odd. Okay, do you guys remember from last year the bouncing and not bouncing? If the power is raised to an odd number, it goes through the point. If it's raised to an even number, it bounces it off. All three of them, we're going to end up going through them. So we're going to go through the first one, we're going to go through the second one, and we're going to go through the third one, and it ends down. A negative odd function should start up and end down, which it does. But I'm not done. I sketched it. Now they want me to tell me when is my y values greater than 0 and when are my y values less than 0. All they're asking you to do is where is your graph positive at? Isn't my graph positive when I'm shading in the red area? That's this one right here. When is my y positive? My y is positive from a negative infinity to a negative 3, union with 0 to 3. The next question it's asking is when is my graph negative? And I'm going to do that in green. Where is my graph negative? It's all the part that's below the x-axis, which is here and here. So where's my graph negative? My graph is negative from a negative 3 to 0, union with 3 to infinity. I do not use brackets. Why am I not using brackets? It's because there's no line underneath greater than and less than. It needs to be greater than that. It cannot be less than or equal to, or greater than or equal to. Okay, I want to do one more, and I think that's it. We're going to do the same thing. We're going to figure out the positive part of the graph, the negative part of the graph. So the first thing I need to do is to graph this. First thing I need to know is my end behavior. My end behavior is x to the third. I know it starts down and it ends up. So I know that that's what my end behavior looks like. But I need to know where this graph crosses the x-axis at. So I need to go all the way back to chapter 1 and figure out how to factor 4 terms. How do we factor 4 terms? How do we factor 4 terms? By grouping them. I'm going to group the first 2 together, and I'm going to group the last 2 together. Okay, the reason why I changed that negative 27 is because I brought the negative sign out. If I bring the negative sign out, if I do the distributive property, I'm back to what I did to the beginning. You got to be really careful with that negative sign when you group. After you group the first 2 and the last 2, I'm going to take the GCF out, which is x squared, and I'm going to be left with x minus 3, minus, I'm going to take a 9 out of this group, and I'm going to be left with x minus 3. Then, I'm going to take what they have in common with each other, which is x minus 3. What do I have left if I take an x minus 3 out of the first part? An x squared. What do I have left if I take an x minus 3 out of the next group? I'll have a minus 9. And what am I going to have left is an x minus 3, x minus 3, and an x plus 3. So, I really have an x minus 3 raised to the second times an x plus 3. And why am I factoring? I'm factoring so I can figure out where it crosses the x-axis at. It crosses the x-axis at a positive 3 and at a negative 3. Those are the only 2 spots that it crosses the x-axis at. Okay, are you ready to graph it? I know I start down. Okay, I know I start down because of my end behavior. And at a negative 3, I'm going to go through. Why am I going to go through? Because it's an odd power. But when I hit the 3, I'm going to bounce off and go back up. Why am I bouncing off? I'm circling this 2 down here. It's an even function. Now I can figure out where my graph is positive at. It's positive in all the red. So my answer for positive, I'm just going to put positive if that's okay with you guys. It's from a -3 to infinity, except at x equals 3. Remember, they want everything greater than the x-axis. They don't want including the x-axis, so that's why I got to exclude this spot. Where's my graph negative? I'm just going to color it in red, in green. It's negative from a -infinity to a -3. Okay, I did not hand out the slip of paper yet, but on 4.1, you're doing 1 through 23 odds. And it's due tomorrow. It's only a 1-section day. Tomorrow is going to be a 2-section day.